Okay, how are we all doing? Yeah? Uh, how's your semester going? Almost over. This is the home stretch. Um, Anybody thinking about a change in career direction? Ice cream taste tester. That's a good plan. Um, okay, so we're basically we're almost done here. Um, so we have 3 lectures left in this class. Um, Next week, I think we'll focus on doing a review and before the exam, and then finally a secondary review where it's more or less open question period that you can ask me whatever you want, and I won't have anything too much to lecture about. Um, Now today I want to just finish up with Java. So there's a lot in Java, and I went over the basics as well as some of the data structuring type stuff. But really, the way to learn anything is just to build something. So the way to use any language is to build something. So I started thinking about putting something together, and while I was thinking about that, I realized there's maybe a few things we didn't cover that would be useful for you and could be stumbling blocks if you've not programmed in Java before. So I think we can get this done today. Let's make a game of tic-tac-toe, text-based game in Java. See if we can bang this out in the time that we have, which is about an hour and 10 minutes now. Okay, so Java is an object-oriented language, so we need to decide on some objects that would be useful in a game of tic-tac-toe. And the first one I can think of actually is the board. So that's the playing surface, the grid that you draw in tic-tac-toe. So is there anybody who doesn't know what tic-tac-toe is? Okay. So tic-tac-toe is a game where you have a 3x3 grid, and 2 players take turns filling in a square of this grid. The player 1 is called X. He or she puts X's in a square. And player 2 is called O. And the game is over, so they take turns filling in an empty square. And the game is over whenever one of them makes a line of 3 of their own symbols. So for example, X wins in this game. So a player can win by making a horizontal line like this, a vertical line like this, or a diagonal line like this or like this. So there's, I guess that's 8 ways to win the game. And so somehow really fundamental to this is the board, this grid that we start with. So we should have a look at that. So let's create a class for that. So how could we represent this board? Yeah. So an array. We could do a multi-dimensional array. In this case, it would be a 3x3 array. So an instance of this board class should have a 3x3 array associated with it. And what should go in that array? What kinds of things? Yeah. Is Boolean enough? Yeah, there's nothing, there's X, and there's O. So we want to be able to store at least 3 different values. Yep.
Can Boolean be null?
No. No. Booleans are either true or false. There's no null. They're a primitive data type. There's no they're not objects, so they can't be null. So we need more than 2 values. So let's use the data type that can store 4 billion values. Why not? So we'll have this thing called the board, and the board will be a 2-dimensional array. That means it's an array of arrays. Right, so remember, if I put square brackets after some type, that means an array of that type. So this says that, well, this is an array of ints, and it's an array of ints. So we'll want to have this thing called a board. And, well, it's going to store ints. One of these is going to represent O, one of them is going to represent X, and one of them is going to represent nothing. So let's just let's give those things names. So let's say static int X equals 1. Let's say O equals 2, and maybe nothing equals 0. Okay, so that's what our board is going to contain. So I find after working in Python all semester, I can't write 2 lines of Java code without making a syntax error, so I'll try and compile a lot. This is where an IDE would be helpful, but like I said, when lecturing, IDEs aren't great because there's just generally not enough space up there to use large fonts. So classes in Java, like in Python, need to have a method which initializes them. And in Python, that's called init. In Java, it's just a method that has no specified return type, but its name is the name of the class. Okay. So this is a class that called board. So it gets this method called board. It doesn't return anything. And well, so what should it do? Well, it's going to take this variable here, board, that we've defined. There's one for every instance of this class, and it's going to make a new integer array out of it. So a 3x3 integer array. Okay. Anything else we need to do? And when to initialize one of these boards? Yeah. Yeah. So so what we would like is all of the entries in this 3x3 array to be initialized to nothing. We don't want X's or O's in there to start with. We want to start with an empty board. Now the nice thing about Java is that every time you allocate an array, it actually assigns default values to the contents of that array. And what values are assigned depends on what kind of array it is. The nice thing is integers, they get assigned the default value 0. And we just, per chance, define nothing to be equal to 0, so we get that initialization for free. If not, we would have something like this.
Do we even need 0 then? That's nothing?
It's just it's a nice name that we can use in our code so that, yeah, otherwise you may look at it and say, why is it being compared to 0? What's 0? Yeah. So otherwise we would have some piece of code like this. This next code is not necessary. 0 is the default int value in Java. But I'll leave it there because if you're programming in a different language like C or C++, then when you create a new array, you just get some garbage that happens to be stored in the array, and so it is important to initialize it. But Java, not necessary. Okay, good. No syntax errors yet. All right. So what kinds of things? Well, it's always it tends to be handy or a cheap way to keep to do testing of small parts of your code, so-called unit testing, is just to include a main function with each class. It's not always the recommended practice, but it's one way to do it. To include a main function that tests some of your class. So here, to create a new board, I declare it, new board called BD, and say that's equal to a new board. So it runs without crashing. We're able to create a new board. Fantastic. So what kinds of things would you do with a board? Yep.
Probably have it output the values on the screen.
So we would probably like to print it somehow. Okay, so let's write a method called public. Let's see, if we're printing it, we probably don't need to return anything. We'll call it print on. And it'll take an argument called a print stream that is what it should be printed on. So print stream, system.out is a print stream. So we can use, instead of writing system.out everywhere, we can just write W. And then if somebody changes their mind and they don't want to use system.out, but they want to use something else, they can ask us to use a different print stream. So it's both works as a shorthand and makes it a little bit more modular. Okay, so we would like to print this thing on a print stream. So what will a board look like? Well, let's see. So it's 3 by 3. So we'd like maybe to just print out the 3 rows and the 3 columns and their values. So let's say I equals 0, I is less than 3, I plus plus. So it's incredible how often you can introduce a bug when you copy and paste a for loop like that by forgetting to change one of the 3 indices in it. So catch me if I'm doing something like that. All right, and so what I would like to do is something like w.print board at I at j, right? So is that going to work? We can try it. So let's say bd.print on system.out. We get a bunch of zeros, 9 zeros. So we're missing one thing, which is a new line after the first row. So we better print a new line after each iteration of the outer loop. So there we get our 3 by 3 display, but it's showing all zeros, and zeros kind of look like O's, which isn't good if we're trying to do tic-tac-toe. Zeros are supposed to be empty things. So let's be a little bit fancier, and let's try a little trick here, which is to define 3 strings, and let's call them, I don't know, labels. So we'll create 3 labels, and those labels will be a string which is just spaces, a string which has an X in it, and a string which has an O in it. Okay. And the reason for that is this string at position 0 is just a blank space. At position 1, it's an X, and at position 2, it's an O, and that corresponds with these three types of values that we intend to store in this array. So it's not board at I at j that will print, it's actually the label that gives us. Now it prints nothing because the whole board is blank. But we could test it a little bit maybe and say, let's say bd dot board at 1, 2 is equal to x. And then print it again. And then looks like it's that x is in the right place. But maybe we could make our board a little bit fancier now and actually frame it all up and everything else. So, so if we want to do a nicer version of this printing thing, maybe what we should do is put some vertical bars and horizontal bars, do some ASCII art. So how many vertical bars are in this picture? 2. And if I'm drawing this picture line by line, when do I draw those bars compared to when I would draw the symbols? So after the first and before the last. So after I draw this, I would draw a bar. And then after I draw this, I would draw a bar. But after I draw this, I don't draw a bar, right? So that would be if j is not equal to 2, right? This is 0, 1, 2. Don't do it after 2. Don't do it when j equals 2. So if j is not equal to 2, then we will say w.print a vertical bar. See how that works for us. Okay, good. So now we have our vertical bars, and we'd like some horizontal bars as well, and they would come when I equals 0. So we do a line when I equals 0, we print all this stuff, and then we'd like to do some horizontal bars there. And again, I equals 1, we print all this stuff, and then do some horizontal bars. And it's only when I equals 2 that there's nothing underneath. So let's say print line, and if I is not equal to 2, w.print 3, 9, 11, I think. 11. Nope, we forgot the new line. Okay, good. So that looks like a tic-tac-toe board now, right? This is the drawing of it here. So cheap graphics with ASCII. Okay, now eventually maybe someone is going to want to play this game. Well, probably no one will ever want to play this game, but let's pretend. And it maybe would be handy. I mean, we have to think about the user interface, and somebody has to, player X is going to have to say, put, you know, my X here. And this is a text-based game, so they can't just point at the screen or click or any of those things. So we should maybe give them some information about how to, you know, how to place their stuff. So we could, for example, put labels on the rows and columns. Labels on the rows. Yeah. So then you'd only have to read one number. I worry that it might be a little cluttered looking, though. It might be. I mean, it's not a particularly difficult game, but it means now every box has something in it, so you're kind of digging around for the X's and the O's. Well, let's just go with the rows and columns, maybe. Although I agree that's probably a nicer interface. No, it doesn't get any worse than this. So now we'll do some guesswork. 1, 2, 3. That's a little too far there. Okay, so if you don't put two of them side by side, they're not too bad. You can see the row numbers and the column numbers. Okay, good. So now we can, it seems we can print a board. What else should maybe boards be able to do? Yeah.
Take user input.
Tough to say. I would rather put that in somewhere else to actually dealing with user input. I'd like to put somewhere else, but I will do something similar to that, which is make a move. So let a player make a move. So that would be something like public, let's say Boolean, and we can call this thing make move. And you specify the row, you specify the column, and you also specify the player. So the row and the column will be between 0 and 0, 1, or 2, and then the player will be this X or O. So this this method somehow should do some error checking, maybe. So maybe the best place to decide whether a move is a legal move or not is in the board, because it knows everything about what's on the board. So we'd like to check to see if this is a valid move. This is a valid row, a valid column, and valid player. So what does that check look like?
If it's not equal to 0.
If the player is not equal to 0?
Whatever the player inputs is not equal to 0. Or we're checking if the spot is empty or not, right? The
Well,
spot is empty is 0, so if it's not a 0, you can't play.
Okay. So somewhere we'll want to say if the board at row and column is not equal to nothing, then we will return false. So this thing is going to return true if you were successful in making the move, or false if it was an invalid move. Okay. Anything we should check before that? Any other arguments that could be wrong? Yeah. So what's an invalid row? So if the row is less than 0, and here's one of the things I forgot to mention in the review. In Python you would say, or if row is bigger than 2, or if column is less than 0, or if column is bigger than 2. For you Java programmers, is that right? No. Or doesn't, the letters OR don't mean anything special in Java. If you want OR, it's 2 vertical bars. So if the row and column numbers are wrong, so if they're if they're negative, that's a problem, and if they're bigger than 2, that's also a problem. So we'll return false there. And notice that the order that we do these checks in, there's a good reason for that. If we do them in the other order, then if someone gives us an invalid row number, then the program will crash when we try and use it as an index into this board.
Give us letters.
Well, the user can't, we don't know what the user can do yet, but we do know that the input to this argument, this function, has to be an int. So that's one of the things that you get with this strong typing that Java has, is you don't have to worry about this thing being a string or some other weird thing. It's going to be an integer. And if it's not less than 0 and it's not bigger than 2, then you've narrowed it down to 0, 1, or 2. So that's the kind of thing you can't do in Python. I mean, they can give you pass in anything as any argument to a function, and it can be difficult to check that it's valid. This is one of the purported advantages of languages like Java for developing big systems, is you don't get these crashes these crashes don't even these things don't even compile when someone tries to pass the wrong kind of argument to a function. Okay. All right, so we've checked that the row and column are valid, that the board is empty. We might as well even check then that it's a valid player. So if the player is not equal to x and the player is not equal to O, then that's also invalid. And finally, once we've checked all that, we just say that the board at I, at row, column is equal to the player. And so now instead of saying BD dot board at 1, 2 equals x, we would say BD dot make move 1, 2 x. So let's make a couple of moves to see how it goes. So we start with an empty board, x plays 1, 2, and then O plays 0, 0. See if that plays out the way we think it will. Nope. So it tells us that there's a missing return statement, and there's a missing return statement, or it thinks that because we said that this function is going to return a Boolean value, and it returns false, it returns false, it returns false, or it gets to the end and there's no return statement there. That's where we should be returning true, because the move was successful. Okay, so empty board to start with, then x at 1, 2, and then O at 0, 0. rows. Just clean up the formatting a little. Okay, so now we can make moves on this board. What else maybe should a board be able to do? Clear itself? Okay. Yeah, so actually the hardest part of this thing, or the biggest challenge that a board has, is to check to see if there's a winner. Right, so it's got to look for all these 8 different ways of this thing winning. So let's see how we would write a function that does that. So we'll write this function that's supposed to decide if there's currently a winner on the board, and if it is, it'll return the winner, and if there's not, it'll return nothing. So how would we do that? So what's the definition of a winner?
If top row, or from left to right, any row is completely full or any diagonal.
So if any row is completely full with the same value.
Yeah.
Okay.
Row, column, or diagonal.
Okay, so let's see. Let's try the rows first. So this loop will iterate over the 3 rows. And so what does it mean for a row to be, let's say, row I to be full? Well, that means, or to be winning, well, that means that the board at I at 0, so for example, if I is 0, I at 0 is there, that's equal to the board at I at 1. So this has to be equal to this, and this has to be equal to this.
Would we just add up all the first row numbers? Because if it's 1, 1, 1, if it's equal to 3, then it's winner of player 1. And if it's 6, then it's equal to the winner of player 2?
Well, if it's equal to 3, it could be a 0, a 1, and a 2.
Oh yeah, true.
Yeah. So if you have X and O playing in the row and a blank space, then you'd get a sum of 3. But actually that is a way we could do it if we were maybe a little bit more careful about the numbers we had chosen. So that if you use bigger numbers that are spread further apart, you could probably make that work. But I'm not sure it would be any simpler, but whatever. Okay, so if this happens, that means the row, everything in that row is equal. So who's the winner then? They're all equal.
Whatever I is equal to.
Okay.
So,
Or
oh wait, no, wait.
they could all be zeros.
Yeah.
This one, I is 1 or 2. Whoever played less.
Could you do an if statement? It's like if I, or no, if that
Well,
spot is, if that specific spot.
maybe we should just exclude the 0 case. So if they're all equal and they're all equal to X, great. If they're all equal and they're all equal to O, great. But if they're all equal and they're all equal to nothing, then that's not terribly useful.
Well, we're doing an if statement, right, that checks if one entire row is the same.
Yeah.
So then after that, could we do an if statement that says if position blank is equal to this number, then the guy wins. If it's equal to a different number, this guy wins, and else nobody wins.
We could do that, but I think we could do it more, we could do it a shorter way as well. So we have a winner here if the board at I at 0 is not equal to nothing and these other conditions hold. So this thing here is not empty, and it's equal to this, and it's equal to this. So there's definitely a winner there. And we know who the winner is. It's whatever value is stored here. So we can just return board at I at 0. Okay. So this is the check for a row winner. And, well, we can throw in another if statement here that checks for a column winner at the same time. And this is exactly the kind of cut and paste that leads to mistakes, so be careful. So instead of I0, I1, and I2, we want 0i, 0i, 1i, 1i, and 2i. So we'll check each row, and we'll check each column. All right. What next? The diagonals. And the diagonals, we could be fancy and do a for loop for those, or some kind of loop for those as well, but it's not really any shorter since there's only 2 of them than writing them out explicitly. So we would say if the board at 0, 0 is not equal to nothing, and the board at 0, 0 equals the board at 1, 1, and the board at 1, 1 equals what? If I'm doing a diagonal, I should be comparing this to what? So where's the board at 0, 0 in this picture? Top left corner. Where's the board at 1, 1? Here. 1, 1. So what's the next one to check? The board at 2, 2. Okay, so if all of those are equal, then we'll return that. And what then are the coordinates of the other diagonal? Okay. So if the top right corner is equal to the diagonal, and the diagonal is equal to the bottom left corner, then we'll return So this actually ends up being bad operands. Anybody see the problem there? No, not yet. That is a problem as well, but do you see what this error is referring to? What's that? Yeah. This is the assignment operator, not the quality testing operator. And then the next mistake would be that we forgot to return anything. So we ran all of these tests and we did not find any winner, so then we'll return nothing. Okay. And we can maybe check this. say BD winner. And what did we call those things? Labels. So we can do this to see who the winner is. So in this case it says the winner is blank. And if we can make a couple of moves. So we have X at 1, 2. We can put it also at 0, 2. And we can put X at 2, 2. So it didn't find that winner. Why not? Did it? 0i, 0i, 1i, 1i, 2i. That looks okay. 0i on the return statement. Okay, good. So the winner is X. So we happen to hit the bug that was in there with that test case. And if you were doing real serious development here, you would test this more thoroughly, but we don't have a ton of time, so we'll leave it at that. Okay, so now we have a pretty decent board that can well, print itself. It can take a move and check to see that it's valid, and it can even determine if there's a winner. And so let's, one thing that was suggested is maybe it should be able to clear itself. So we already wrote the code for that. We might as well just use it. So that clears it. So a few things you notice here different from Python is we're defining a class and it has all these member functions: clear, print on, make move, and winner. And if we want to use them within the class, we don't have to always say self or this or anything to declare them. So this thing knows that when I call clear, the first place I should look for a function called clear is defined inside this class, so it will actually call this one. I didn't have to say self, specify that this was self.clear or this.clear. Okay. So we're happy with our board class. What else do tic-tac-toe games have? 2 players. So let's make a player class. Okay, and well, so we'll want a method to create a player. And what sort of properties does a player have? What's the main property? Yeah, so the really critical thing here is whether the player is player X or player O. So let's say we'll call that the player's value. And we should save that. So players will have this property called a value.
You kept track of
Yeah, we'll do that in. We'll do that as we're running the game. But for instance, it's handy to have two different players because, for example, one of the players could be a player who reads moves from the user. The other player could actually be a computer. So there's a chance, we could write a subclass of player which is human player, and another subclass which is computer player. Maybe another subclass which is player who lives on an island and sends his moves through a bottle that he throws in the ocean. So this gives us a little more flexibility later. Okay, so the player, when we create him, he saves his value in this instance variable called value. And this is something else that Java has that Python doesn't. When we want to refer to this object that we're currently working on now, the thing that received this message, there's this special variable called this, and it always refers to this object. This is the equivalent of the thing that we always call self in Python. And here we have to refer to it explicitly because otherwise it's going to think we're talking about this value that was passed in here. Okay. And, well, the main thing that a player does is to make moves. And this is where different kinds of players, if we were going to do something more sophisticated, might implement this in different ways. But we'll live with human players for now. If we wanted to grow this later, we could make this a superclass of different kinds of players. But let's say make move. Now, in order to make a move, what does a player need access to? The board. So maybe make move should take an argument called the board, which is a board. Okay, so we'd like to maybe print a message for the player. So let's say player and I'll do something a bit funny here. So I would like to print X or O, but what I have is this integer value for this player. But I know that in the board class, there's this array called labels, which will let me turn a player number into an X or an O. So board.labels at value. Make your move. Okay, so we would like this player then to make a choice here, to input some information for us. And how do we do that in Java? Scanner. Okay, so that means we're going to need a scanner. And we'll want that on, we're going to read from the console, so that's on system.in. Okay. So I'll keep, so we'll start setting up our testing code. Okay, so I have this scanner. Scanner is a thing with all of these nice methods associated with it. The particular method that we're interested in is the next_int method. So we want something like to say the column is, or the row is next int, and the column is next int. So let's see how far we've gotten here. Okay, so make move needs to have a return type. I don't want to return anything, so I'll make it void. Don't be alarmed at all the errors. If you get a lot of errors, go back up and look at the first one. It's often the cause of many more that come later. In this case, it says it can't find scanner, and that's because scanner is not part of the Java, the main Java language. It's part of the util class. And of course, this next int is something that scanners do. Okay, so this gives us this this display and asks the player to make their move. And I don't know, the player can say 9-7, doesn't matter because there's no code after that. So now what we would like to do is try this move. And we already wrote a good some good code for board that will check to see if the move is valid. So we could just try it, and if the thing returns false, we can deal with that. So in board, that method was called make move. It takes a row, it takes a column, and it takes the player. So we'll say board make move row column, and the player, or what the board thinks of as a player, is just this integer value that we're storing, which is either x or o, or 0 or 1 or 2. Okay. So we can try that. So let's say I want to move 0, 1. Indeed, that works. Let's try 1, 1. That works. Let's try 1, 2. That works. So that all seems to work. But of course, if I do 4, 9, then nothing happens. So in this code, I know nothing will have happened because the return value from here will be false instead of true. All right, so I'd like to ask the player again in that case, right? So how would we structure that? Well, the easiest way I can think of is to say, create a Boolean value called done, which is false. And while we're not done, we do all this and set done equal to the return value. So the first time we get to this loop, done is false, so not done is true, so we execute this loop. And at the end of the loop, done is only true if the move actually happened, if it was a valid move. Yeah? If done is false, then recurse, let's say. Yeah, that would work too. Yeah, that would be fine. It might open you up to Stack Overflow, but that somebody would have to sit there and do it about 20,000 times to make that happen. Maybe a bigger danger would be that a Stack Overflow could occur because they entered something that's not a number, and so the scanner keeps just returning garbage, but we'll see. So if I do something like a 5, 6, it just asks me again. Okay. And we're still not completely robust here, because if I enter something like AB, you get this kind of error here. Do you want to handle those errors or not? I might as well show you, just so you know how exception handling works. So similar to Python, you make a try block around the code that you're worried about. In fact, try and keep that thing as small as possible. So the error is not going to happen when we create the scanner or when we print. It's going to happen here. And then you catch whatever exception has occurred. In this case, actually, there's nothing that I want to do in particular. In this case, it's enough that, that the exception occurred. I'll catch it. Done will still be equal to false, and this loop will enter, go back another time. Check that. So, seems to work, but if I enter something valid, it's good. Yep.
What does the exception mean?
So we saw this thing that was thrown. We can go back and look at the error messages. So when Java has any kind of exception, it throws, well, like in Python, it throws, in Python they're called errors, in Java they're called exceptions. And often there's information associated with them. So when you catch one of these exceptions, it assigns it to this variable e. So in this block of code, I could do some stuff that depends on this exception here. In particular, most exceptions have a message associated with them, so I could say something like .println e dot, I think it's MSG. I think that's the message that tells you a little bit more about the exception. Yeah, you could try and do different things depending on the exception. And here I say exception because it's the superclass of all possible exceptions. So this will catch anything bad that happens. It's generally not a great idea. Usually you would just try and catch the ones that are more specific. So in this case, an input mismatch exception. But we could. That will work too, and means that we won't catch exceptions that are much wilder than that, null pointer exceptions and other things. So we're catching that input mismatch exception and nothing else. Okay, good. So we've got our player. So now we're just about ready to make our game, right? I think we're ready to go. We have a player who can make moves, a robust input system. Yeah.
Well, we have to check if the board is full originally.
Yep. So we'll have to have that somewhere. We'll decide where. Maybe as part of the game, maybe somewhere else. But let's see. So now we want the actual game, and we'll do a fairly standard trick, which is just to make a class whose job is to be the application. So let's call this thing. Is that how you spell tic-tac-toe? Okay, so if we're going to play a game, we'll need a board. we'll need a couple of players, and again we'll use an array trick that we'll put our two players inside an array and say player array players is an array with a new player who is X and a new player who is O. All right, so now what does the game loop look like? We have our board, we have our players. What happens next? Okay, so let's say while winner, so boards winner, let's say equals board dot nothing. So there's no winner. We say what? Somebody has to play, right? Who plays? Players at 0 or players at 1? We alternate. So let's keep a counter. And if the counter is even, it'll be player at 0, and if the counter is odd, it'll be player at 1. And that's just another way of saying the counter modulo 2. Okay. And the player that was called make move, and you have to give it the board, which is called BD. If what equals 0? Yeah. It's the right-hand side that you're worried about because that's like dividing by 0, right? You're saying what's the remainder if I divide I by 0, and that's bad. But 0 divided by something is there's no problem. It's just 0. Okay, so then that guy makes his move, and maybe we should. At the beginning, we'll print the board. bd.print on system.out. Maybe after the player makes his move, we'll print the board. And once the game is over, we can say the name of the winner. Okay, player X, make your move. So who wants to be player X? Okay, middle. So tell me what that is. 1-1. Who wants to be player? Oh, X again. X. Ah. We forgot to increase our counter. Well, we can finish this game. 0-0, 2-2. Player X won.
Game I cannot lose.
Okay, player X, make your move.
1-1.
Who wants to be player O?
0-2.
Okay. 0-2. 0-1. 2-1. 0.
2.
1, 2. And I lost.
Oh. 2-0.
Player 01. Great. So, is the game completely done? We've got this stalemate problem. So if we get to there, then we're really in a pickle because the board fills, then player X is asked to make a move, and there's no valid move, so he's stuck there, and it just keeps saying invalid move, invalid move. So this thing will go on forever. So so we need some way to deal with that, and well, that says maybe this board class should have another function in it, which is we can call it isFull. It will return true if the board is completely full. Yeah, so there's another way to do it. We could ditch that entirely. How many moves? 9 moves. So that means the value of I should be what?
But does that also account for someone in the same spot?
Okay. So while I think is less than 9, and the winner is that, we should do nothing. Is that right? Let's do a quick try. Okay, 0, 0. Yeah, so now I have to try not to win. Okay, so X shouldn't play, so X should do, X is going to win no matter what now. Yeah. Good one. Okay, so not to win.
X should go in the middle.
Well, somebody's got to go in the middle.
Yeah. But if O is in the center, there's a lot more ways to tie.
Okay, so let's put O in the center, and then now we should be able to alternate or something. Yeah. So let's put X at 0, 2. O at 2, 0. Yeah. X at 2, 2. Let's block 1, 2. Okay, I think we're safe now. No, no, no. 1, 2. No, 1, 0. All right, and 0, 1. Finally, 2, 1. Okay, player blank 1. Good. So it finished exactly when it should have, and then you might want something like if bd.winner is not equal to board.nothing, or okay, so there I think we have a complete working game of tic-tac-toe. So who wants to play? Sure. you're going to be player X.
Okay. 0, 1.
0, 1. Player O. You can, sure.
2, 2.
Player X.
0, 2.
What do you say? 0, 0?
Yeah.
1, 1.
All right.
2, 1.
2, 1.
Oh, he was. Make sure I don't screw this up. 2, 0.
2, 0. Player X wins. Okay, good. So so there you go. That's the last Java application I'm going to write in this course.